Hope you spent your vacation nicely. Okay. Are you there? Present?
Yes, ma'am.
Yeah. I think it's like once upon a time that we have met. Yeah. So, sudden vacation and sudden re-entry of the sessions. Okay. Hope you remember. I'm your. I'll come. I'm your chemistry teacher. I'm Cheta. I was teaching to you about the electrochemistry topic. Good morning once again. Okay. So we shall do a small revision session and quickly go about with the discussion of the related topic. Okay. So hope you have you can recollect. You have your notes on hand. Please to keep them near you. It will be helpful for you to go ahead with the discussion. Okay. And I have a small question. Is the view clear? You need to be little loud. Is the view clear?
Clear, madam.
Clear? Are you able to see the board, whiteboard properly?
The whiteboard is quite blurred, ma'am.
But the letters on the
Huh?
board are
It's
blurry.
quite blurred, ma'am.
It's a little bit blurred.
Yes, ma'am.
Okay. I think that's because of the light there. Now, how is it now?
Same, ma'am. Blurry.
Board is still blurred?
Yes, ma'am.
The camera is not focusing the board properly, ma'am.
Camera is not focusing the board properly.
Ma'am, move the board closer to the camera.
Yeah. Actually, this is what I feel very convenient. So what I was trying to do is, I made this setup available for me during the vacation time. I bought few stands out there, and I felt this is a little convenient for me. But then, before I just go ahead with my lecture session, I need to be really clear that whatever you're seeing on the board is clear to you or not. Is it clear? Is my voice clearly audible to you all? Hello?
Yes, ma'am.
Audible.
Am I audible? Well, again, we have got back to our same old discussion. Am I audible? Is the board clearly visible? Is the board visible a little bit better?
Yes, ma'am.
Yes, okay. Ma'am. Then we'll quickly start our session. I think you have good idea about the basic concepts. Hope you're carrying your notebook along with you. You have written good number of points out there. Correct? What was the last point I told you? Roll number 101. Good morning. Roll number 10. Yeah. Good morning. Yeah. Tell me. What was the last point, Shrishma, that I've told you?
Electrochemical series.
About the electrochemical cells. Good. So what are electrochemical cells? Come on.
It is a chart or table containing the standard electrode potential of various metals and non-metals placed in increasing order. Of
Shrishma,
standard. Yes, ma'am.
just recheck what you have answered. What is the last point? I talked about electrochemical cells or EMF series.
Series, ma'am.
EMF series. Okay, so you're talking about the EMF series. Okay.
Yes, ma'am.
Antenna?
Yes, ma'am.
Yeah. Okay. So that's the definition of EMF series. Okay. It's point number 23. No, it's a wild guess.
25.
25. Okay, good. Okay, so Shrishma, so what it is the tendency of various metals and non-metals to lose electrons is increasing or to gain electrons is increasing
Cappuccino.
down the EMF series.
Electrodes with less or circle
Shrishma,
value occurs
you
in
there?
Yes, ma'am. I
Cappuccino.
didn't get.
Taran, will you mute your mic, please? Thank you. Taran, 1 second, please mute
Sorry,
your
ma'am. Sorry, ma'am.
mic. Okay. Now, Shrishma, tell me, what is oxidation and what is reduction? Quickly, come on. It's easy. All you can do it. Please do not
Gain,
switch on your mics unless I call your roll number. Okay, come on, quickly we'll do it. What is oxidation? What is reduction? In
gaining
terms
of
of
electrons.
change. Amma, enana?
Gaining of electrons, ma'am.
Is gaining of electrons is
Reduction.
reduction. Good. What is
Losing of
oxidation?
losing of electrons.
Yes, losing of electrons is oxidation. Gaining
Oxidation.
of electrons is reduction. What is a redox reaction?
Both oxidation and reduction takes place
In
simultaneously.
place simultaneously. Very good. Good going. Okay. Roll number 102. 102. Good morning. Roll number 102. Absent. 103. Good morning. 103 is absent as well. Okay. 104. Good morning. 105. Oh, this means I better take the roll call right in the beginning of the class. Okay. 6. 106. 107. 108. 109. 110. 11. 12.
Yes, ma'am.
Yeah, good morning.
Good morning.
Yeah. Kiran, tell me, what are electrochemical cells? Kiran,
Yeah, ma'am.
what are electrochemical cells?
I didn't know, ma'am.
You don't
Last,
know.
yes, ma'am. I didn't listen class, ma'am.
This is the first class you're attending.
I attended, ma'am, but I not listen. I absent some classes.
Please be regular, Kiran.
Okay,
These
okay,
are
ma'am.
all actually 10th class questions, but you can, sometimes it happens, but I expect you to be regular henceforth. Okay?
Okay, ma'am.
Get
Okay,
up
ma'am.
with the points I'm giving. Okay? Notes will be provided to everyone. But
Okay, ma'am.
catching up with the notes and writing something, scribbling in your answer scripts is not what is the method of learning. Okay? Okay.
Okay, ma'am.
Next. 113. Roll number 113. 14. 15.
Yes, ma'am. 14.
14. Yeah. Vinay,
Yes, ma'am.
good morning.
Good morning, ma'am.
What are electrochemical cells?
Electrolytic cells and galvanic are voltaic cells.
Correct. Ante aventi. What are they? Electrochemical cells are of two types. They are electrolytic cells The other one will be galvanic or voltaic cells. So exactly what are these electrochemical cells?
Electrolytic cell which converts electrical energy into chemical energy.
Good going.
Galvanic cells which converts chemical energy into electrical energy.
Very good. And the whenever I say the word a cell is a combination of what two things?
Anode and cathode.
Very good, lovely. Anode and cathode.
Cathode.
Every time, whenever I use the word cell, it is a combination of an anode and a cathode. Now tell me, Vinay, what is anode and what is cathode?
In galvanic cell, what ma'am?
Any cell. I'm not asking about the sign or symbol of the electrodes, but I'm asking what they are. What are electrodes? What is anode and what is cathode? Okay.
Combination of energy.
Oh no, combination, eh? What type of reaction takes place at anode? What reaction takes place at cathode? Irrespective of the type of the cell it is. Ante, this point, I think, can anyone answer? What type of cell reaction takes place?
At anode,
Anode
oxidation takes place, ma'am.
Oxidation, ma'am.
Cathode reduction, ma'am.
Cathode reduction.
Mm-hmm. Is it same in electrolytic cell and galvanic or voltaic cells?
No, ma'am. Different, ma'am.
Same, ma'am.
Same, ma'am.
Same, ma'am.
Signs will
Same.
be different, ma'am.
That's it. That's a discussion. No matter whether it is an electrolytic cell or a galvanic or voltaic cell. In both the cases, anode always includes oxidation reaction. Cathode is associated with the reduction reaction. And in general, I should say in the general application by IUPAC convention, anode is generally by standard on the left hand side and cathode is on the right hand side. The sign of anode and cathode might be variable, means it can be positive or negative depending upon the electrochemical cell. If you're talking about an electrolytic cell where you're connecting the electrodes to an external power source, that is DC power supply, anode is generally positive, cathode is negative. Whereas if you're talking about galvanic or voltaic cells, anode is negative, cathode is positive, exactly opposite. But in both the cells, at anode oxidation takes place and cathode reduction takes place. And this simultaneous oxidation reduction reaction, that is redox reaction, gives the electrical energy in the case of galvanic cells, or this electrochemical reaction or redox reaction is brought about in the electrolytic cells. Okay, so that's a whole idea behind. Okay, and for that, I think I gave a really elaborate, very, very long introduction about the various definitions of the terms that are generally used in electrochemistry topic, okay, which are very, very important for your conceptualizing of this chapter, okay. But our main focus in this chapter is all about the galvanic or voltaic cells. Generally, they'll call it as an electrochemical cell, but we are addressing the galvanic or voltaic cells in this chapter. That means the cells in which a spontaneous chemical reaction is giving electrical energy. Okay. In general, what it is found is that there are many chemical reactions which are taking place spontaneously. But then when we are considering the electrochemical cells, we are always focused on two things: whether the spontaneous reaction is able to give a net electrical output. Okay, so how to bring about these things? In such cases, we construct what is called electrodes, which are supposed to be various metals dipped in their own metal ion solutions. So I want a spontaneous chemical reaction to give net electrical energy. Usually, what will happen when a spontaneous chemical reaction is taking place is it is associated with the liberation of heat energy. Okay, but then I'm not interested in tapping that heat energy and making and converting it to some other form of energy. I directly want that chemical reaction to give net electrical output for me. Now, how to get that net electrical output for me? Then I'll have to construct the cells in such a way that I should be able to create an EMF or a potential difference between 2 points. As I know earlier that the charge flows from higher potential to a lower potential. So my idea is to create a potential difference between any 2 points. And obviously, I'll start taking an anode and a cathode, and the reaction is spontaneous. Now, how this anode and cathode, that is the electrodes, are constructed? By dipping a metal in its own metal ion solution. Okay, and what would happen? Obviously, because at anode oxidation is taking place, the electrons are released, and these electrons will flow through the wires through some ammeter or voltmeter to the next point, that is cathode. And I know that at cathode the electrons, that is a reduction reaction, takes place. Okay, as flow of charge is nothing but current, I am getting net electrical output happen. Okay, so what I have realized by now, I have realized that the electrode construction is very, very pivotal for me to give the net electrical output. So how the electrode construction is done? The electrode construction is done by dipping a metal rod in its own metal ion solution. Okay, so this construction of electrodes is also given by a technical word called the construction of electrodes in a galvanic or voltaic cell is also called half cell. Okay, half cell is the word that represents an electrode in a galvanic or voltaic cell. Okay, and the reactions taking place are called as half cell reactions. Okay, is the point clear? అర్థమైంది కదా? I think మనం రీక్యాపిచులేట్ చేసేసుకున్నాం. ఏం కాన్సెప్ట్ చెప్పాను? సో ఇప్పుడు నేను గాల్వానిక్ వోల్టాయిక్ సెల్స్ గురించి చెప్తున్నా. స్పాంటేనియస్ కెమికల్ రియాక్షన్, ఎలక్ట్రికల్ ఎనర్జీ ఇవ్వాలి. జనరల్ గా స్పాంటేనియస్ కెమికల్ రియాక్షన్ హీట్ ఎనర్జీ ఇస్తుంది. కాదు నాకు ఎలక్ట్రికల్ ఎనర్జీ కావాలి అంటే ఏం చేయాలి? నేను దానికి అకార్డింగ్ గా సెల్ ని కన్స్ట్రక్ట్ చేయాలి. ఓకే, ఎలక్ట్రికల్ ఎనర్జీ ఎలా, కరెంట్ ఎలా పాస్ అవుతుంది అంటే ఎప్పుడైతే ఈఎంఎఫ్ ఉందో there is always flow of charge from higher potential to lower potential. సో అర్థమైంది. ఎలక్ట్రాన్స్ మూవ్ అవ్వాలంటే ఎప్పుడన్నా హైయర్ ఒక 2 పాయింట్స్ క్రియేట్ చేసి ఈఎంఎఫ్ క్రియేట్ చేసుకోవాలి. ఈఎంఎఫ్ క్రియేషన్ చాలా ఈజీ. ఏముంది, ఒక చోట ఎలక్ట్రాన్స్ వస్తున్నాయి, ఒక చోట ఎలక్ట్రాన్స్ సింక్ అవుతున్నాయి, రెడాక్స్ రియాక్షన్ అవుతుంది. సో ఇప్పుడు ఏం చేయాలి? ఎలక్ట్రోడ్స్ ని జాగ్రత్తగా కన్స్ట్రక్ట్ చేసుకోవాలి. ఎలక్ట్రోడ్స్ ఎలా కన్స్ట్రక్ట్ చేస్తారు అంటే, ఆ కెమికల్ రియాక్షన్ స్పాంటేనియస్ గా అయినప్పుడు ఆ ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ ని కంట్రోల్ చేయడానికి యానోడ్ క్యాథోడ్ మధ్యలో ఈఎంఎఫ్ క్రియేట్ చేయడానికి ఏం చేశారు? ఎలక్ట్రోడ్ కన్స్ట్రక్షన్ ని ఒక మెటల్ రాడ్ తీసుకుని దాన్ని ఒక సేమ్ మెటల్ అయాన్ సొల్యూషన్ లో డిప్ చేసి ఎలక్ట్రోడ్స్ ని కన్స్ట్రక్ట్ చేశారు. అలా ఒక యానోడ్ ని ఒక క్యాథోడ్ ని కన్స్ట్రక్ట్ చేసి ఒక ఈఎంఎఫ్ ని క్రియేట్ చేశారు. ఓకే, సో ఈ ఎలక్ట్రాన్ ఫ్లో వరకు ఏమవుతుంది? వైర్స్ తో పెట్టేసి కనెక్ట్ చేసేస్తారు. ఈ ఎలక్ట్రోడ్స్ ఏవైతే మెటల్ రాడ్ దాని ఓన్ మెటల్ అయాన్ సొల్యూషన్స్ లో డిప్ చేసి క్రియేట్ చేశారో వాటిని హాఫ్ సెల్స్ అంటారు. ఆ రియాక్షన్స్ ని హాఫ్ సెల్ రియాక్షన్స్ అంటారు. అంటే యానోడ్ దగ్గర ఆక్సిడేషన్ హాఫ్ సెల్ రియాక్షన్ అవుతుంది, క్యాథోడ్ దగ్గర రిడక్షన్ హాఫ్ సెల్ రియాక్షన్ అవుతూ ఉంటుంది. ఓకే, సో దట్స్ ద ఐడియా. సరే, అవి రెండు ఎలక్ట్రాన్స్ ఫ్లో వరకు అయితే ఓకే. కానీ ఇప్పుడు ఎలక్ట్రోకెమికల్ సెల్స్ క్రియేట్ చేసావు గాల్వానిక్ సెల్స్ లో, అయాన్ ఎక్సెసెస్ ఫామ్ అవుతాయి. అంటే ఏ సొల్యూషన్ దగ్గర ఆక్సిడేషన్ అవుతుందో మెటల్ ఏమవుతుంది? మెటల్ అయాన్ కింద కన్వర్ట్ అవుతుంది. ఓకే, సో యానోడ్ దగ్గర ఏమవుతుంది? మెటల్ అయాన్ కాన్సన్ట్రేషన్ ఇంక్రీజ్ అవుతూ ఉంటుంది. క్యాథోడ్ దగ్గరకు వస్తే మెటల్ అయాన్స్ ఏవైతే సొల్యూషన్ లో ఉన్నాయో అవి ఎలక్ట్రాన్స్ తీసుకుని రెడ్యూస్ అయ్యి మెటల్స్ కింద కన్వర్ట్ అవుతుంది, అదే మెటల్ కింద. సో ఇక్కడ ఏమవుతుంది? అయాన్ డెఫిషియన్సీ వస్తుంది. సరే, సో అయానిక్ ఈక్విలిబ్రియం మెయింటైన్ చేయడానికి ఏం చేస్తానంటే I'll use an apparatus called or instrument called what? To maintain ionic equilibrium in a galvanic or voltaic cell, I'll use a instrument or an apparatus called a salt bridge. Now, what does this salt bridge does? It does the charge flow in such a way that ionic equilibrium is maintained between the two electrodes. Now, what's the construction of this salt bridge? How it is made? This salt bridge, this is what you might be probably by chance you're coming to the lab, you'll be using this salt bridge, and what you will identify is that this salt bridge has a construction of this sort, almost a V-shaped structure, and this is all glass made, okay, and it is filled with a material called as agar. Agar, it's like a jelly substance, okay, in which it salts like potassium sulfate, ammonium nitrate, sometimes potassium chloride, etc. are used. Now, what is the idea? Okay, these are ionic solids which will quickly dissociate into their corresponding ions, and the ions are having same mobility. That means both the ions would be moving to the electrodes with same speed. That is very important, in fact. Is it not? Because the conductance of any material depends upon the mobility of the ions that are present in it. Okay, we'll see to it that we use such salts which are having same ionic mobility, and hence will be doing. So what is done on the left hand side? I know that there will be anode. Okay, on the right hand side there will be cathode. Anode is negatively charged, cathode is positively charged. So this is anode, and that's going to be cathode. And I'll place this salt bridge in the solution in such a way that as soon as here the metal is losing electrons, here what will happen? Metal gives metal ion, M gives electron. Okay, let it make it less. Okay, so here oxidation. This metal ion is formed. The ions, okay, will quickly go from the salt bridge into the solution, maintain the electrical neutrality. Here, what will happen? Metal will accept electron to form metal atom. So the ions from here in the salt bridge will move here and maintain the electrical neutrality. Here, it's the oxidation reaction, and here it is the reduction reaction. A simple, easy one. Is it not? Fine. Hope the point is clear to you all. Okay. Now have a small thing. Why I've talked about the EMF series to you all? What made me talk about the EMF series? Roll number 115. Good morning. Yeah. Shekhar, Rajashekhar, tell me what made me speak about the EMF series? Shrishma told what it means by an EMF series. What's the importance of that series? Okay. So what it means by electrode potential? Good. So all the metals will have same tendency, or they'll have different tendencies? Did you understand, Shekhar, my point? Will all the metals have same tendency, or they'll have different tendencies? Different is correct. Are SRP values same for all the metals or not? They are very different. So, అది ఎలా డిపెండ్ అవుతుంది? It depends on the nature of the metal. That's it, as simple as that. ఏ మెటల్ ఉంటే ఆ మెటల్ క్యారెక్టరిస్టిక్స్ ని బట్టి it shows the tendency whether to lose or gain electrons. Okay, this tendency to lose or gain electrons is called, Shekhar, what it is called? Good, very good. Also, what defines single electrode potential? The tendency of a metal in its own metal ion solution, showing the tendency whether to lose or gain electrons. Okay, now tell me, how is there any potential difference between a metal dipped in its own metal ion solution, and that is measured as single electrode potential? What is the oxidation state of a metal? 0. So, oxidation state of a metal is always 0. Which metal? Zinc, copper, or any metal? Any metal, if I say metal, it means it's in the 0 oxidation state. Okay? And when I talked about metal ions, it could be a metal with positive sign or negative sign. That means that metal might have lost electrons and underwent oxidation, or it might have gained electron to undergo reduction. So if a metal has underwent reduction, it takes the minus sign, and if it undergoes oxidation, it takes the positive sign. Okay, so the idea is metal in its own metal ion solution. Now, how to find this? That is metal. This is metal ion. Now, how would I know that a particular metal might have underwent oxidation or reduction? How to tell? How to guess? Chuppu. Which metals will lose electrons? Which metals will gain electrons? 17, roll number. Shekhar, your roll number is 16. Okay. Roll number 116. Good morning. లాస్ట్ 20 అంతా కొంచెం నటోరియస్ బ్యాచ్ ఉన్నట్టుందే. 17.
Yes, ma'am.
Yeah, good morning.
Good morning, ma'am.
Vaishnavi. Which metals will lose electrons and which metals will gain electrons? Metals or non-metals?
Ma'am?
How I measured it? How I found it?
Ma'am, ma'am, I didn't get you, ma'am.
Vaishnavi, I've asked you a question. Okay, Shrishma
Yes.
defined what it means by an electrochemical series. Okay. So, and just now Shekhar has told us that, see, it's a tendency of a metal whether to lose or gain electrons dictates its potential, single electrode potentials. Okay. Now, what it means by single electrode potential, the potential difference between the metal and its own metal ion solution. Okay. Because of different oxidation states, there is a potential difference. Am I right or wrong?
Yes, ma'am.
Now, Vaishnavi, you understand the concept clearly. I have a question to ask you. Okay. Now, the electrode potential between Fe plus 2 / Fe is as Fe plus 3 slash Fe plus 2. I'll repeat the question again. Will the electrode potential of the two electrodes, I have placed two electrodes. See, when you just look at the board, just understand that there are two electrodes. One is Fe plus 2 slash Fe, and there's one more electrode
Fe
which is
plus 3 slash
Fe
plus 2.
plus 2. There are two different electrodes. Are these both same or different? Will the electrode potential of these two electrodes be same or different? What's your guess? ఏం చెప్పాను రెండు సేమా బట్ ఎలక్ట్రోడ్ పొటెన్షియల్ సేమ్ ఉంటాయా Fe plus 2 slash Fe, Fe plus 3 slash Fe plus 2 ఎలక్ట్రోడ్ పొటెన్షియల్ సేమ్ ఉంటాయా డిఫరెంట్ ఉంటాయా నీ గెస్ ఏంటి భయపడకు రాంగ్ అయినా రైట్ అయినా చెప్పేయాలంతే నీకు ఏది లాజికల్ అనిపిస్తే చెప్పాలి
సేమ్ మ్యామ్
సేమ్ ఉంటాయి ఎందుకు అనుకుంటున్నావు
because the lose or gain of the electrons in the both of them is same, no ma'am.
Systems losing or gaining the same number of electrons.
Same number of electrons, yes ma'am.
Is it the same? Fe plus 2. Is the board very clear to you? Are you able to see the board clearly, girl? Ma, kanpistunda board clear ga?
Yes.
Fe plus 2 slash Fe plus 3 and Fe plus 3 slash Fe plus 2. I've said these two are two different electrodes. Will the electrode potential of these two electrodes same or different? Come on, quick. Electrode potential same untunda different untunda? Is anyone in the class? Vaishnavi says it is same. Okay. Anyone in the class? What's your answer? How many support Vaishnavi? And you say it is different. Support your answer. Come on. మీరు తొందర చెప్పేస్తే తొందరగా నెక్స్ట్ టాపిక్ వెళ్తాం నేను చెప్పిందే చెప్పుకోవాల్సి వస్తుంది మనం అసలు యాక్చువల్ దాంట్లో ఇంకా జస్ట్ యూఆర్ మైల్స్ బిహైండ్ అవర్ పియర్స్ నో ప్రాబ్లం బట్ యూ షుడ్ అండర్స్టాండ్ ఏంటి
gaining of electrons different ma'am
because
gaining of electrons
different
Energy
ఏంటి డిఫరెంట్ ఉంటుంది కరెక్ట్
because of electronegativity.
Because of charges on.
Correct.
energy difference.
Energy difference. Correct. And it's correct. Now the SRP value of this system is minus 0.44 volts. And this system in which ferric iron is reduced to ferrous iron. Okay, this is called ferric iron and this is called ferrous iron. It is plus 0.77 volts. Okay, so both are different. Why? The electron change during the electrode oxidation or reduction is different. But what you should understand here, every time what I'm showing, Fe plus 2 getting converted to Fe is oxidation or reduction?
reduction ma'am
Reduction. Fe plus 3 is getting converted to Fe plus 2 is oxidation or reduction?
reduction
Reduction. So why I'm writing this is because according to IUPAC convention, okay, it is always the reduction reaction standard we are going to write unless until they are specified. That means it might undergo oxidation or it might undergo reduction. We don't know. But we'll always write reduction reaction to both the electrodes. At anode, oxidation is taking place, but we'll write the reduction reaction and give a negative symbol to represent that it has underwent oxidation, but I am showing the reduction. Okay, like this, what they have done is they have taken various metals and they have dipped in their own metal ion solutions under standard conditions and combined them with an hydrogen gas electrode, which is called as standard hydrogen gas electrode or normal hydrogen gas electrode, whose EMF value is arbitrarily taken as 0 volts. Okay, so how they measured the single electrode potentials of various metals and non-metals? By combining this half cells with another electrode, that is standard hydrogen gas electrode, whose EMF value is arbitrarily taken as 0. Okay, it will not be 0, but we have taken it as 0. And they found the oxidation and reduction tendencies of various metals and non-metals, and bought a series called as EMF series. So in that EMF series, what I have done, I have put the hydrogen gas electrode in the middle. Okay, and I placed various metals which underwent oxidation with the hydrogen gas electrode to the top, and the other metals and non-metals which underwent reduction with the hydrogen gas electrode to the bottom. What ultimately I found that I got a series of various metals and non-metals. Okay, but I saw to it that I have written all the reduction potentials only, and I have put a negative sign for those metals which are underwent oxidation and acted as anode on the top. Lithium topped the series, okay, and has the highest oxidation potential or least sorry, excuse me, and the EMF series. That's what I have told you. Fluorine is at the bottom and acts as a strongest reducing agent. Okay, so was the EMF series. Okay, while explaining the EMF series, okay, always I try to incorporate one point very clearly to you all, that the cell construction, that is whenever I want to make a galvanic or voltaic cell, I need to clearly know which one would act as anode and which one would act as cathode. By thumb rule, what is your guess? Which will act as anode? Those metals which are having less SRP value will act as anode, and those metals which have more SRP values will act as cathode. Okay, and hence is the construction of an electrochemical cell. Okay, now did I explain all these points to you earlier?
Yes, ma'am.
Hello? Yes.
Yes, ma'am.
Okay. Now I have a point to ask. Now, by this time, you all understood that in galvanic or voltaic cells, there are the construction is with the help of two half cells, and there's a salt bridge, and there is an electrical circuit which connects the flow of electrons externally. Okay, so internally there is a flow of ions and externally there is flow of electrons. Okay, and this is all what I want to tell. Okay, for explaining that clearly, did I speak about what is called as a Daniell cell? Did I speak about the Daniell cell? Yes or no? Roll number 116. Roll number 116. 117.
Yes, ma'am.
Okay, Vaishnavi. What is Daniel cell made up of? I think whole class is going, but no problem. Daniel cell allow the mark. 2 electrodes ఏంటి?
Zinc and copper.
Zinc and copper. Okay. Vaishnavi, you should catch up. I hope
Yes,
next
ma'am.
time
Yes, ma'am.
you're more effort at explaining. You're carrying from here by you. Is the point clear? Okay. Right. Now, Prithvi, tell me.
Yes, ma'am.
You said there are 2 electrodes. One is a zinc electrode, the other one is the copper electrode. Which is anode and which is cathode?
Copper is cathode, ma'am. Zinc is anode.
How could you say?
Because at copper, reduction occurs, ma'am.
How would you say?
It has a lesser SRP value.
What?
Sorry, more SRP value.
Okay, good. So you've got back to the point. So what after defining the SR? Good, Prithvi.
Okay, ma'am.
Nice. Okay, I'll come to my point clearly. So by this time, I understood that I need to construct an electrochemical cell. Okay, taking 2 half cells, anode and cathode. And what I have to do is that I should say that there is a net electrical output for the system. Okay, for that, what I'm doing, I'm combining 2 metals. Okay, I'll see to it that at anode, I have a metal with less SRP value, and at cathode, the metal with more SRP value is placed. Okay, so that's the idea. For that, to start explaining about how to speak about an electrochemical cell, I took the example of a Daniell cell. This cell is made up of 2 electrodes, at which at anode I place the zinc, and copper I placed at cathode. Now, how the choice is not random. Please get to know that. So why is because after seeing the EMF series, okay, in the EMF series, we have the various values. All are reduction values. Okay, all values are reduction values. Fine. So what I have done, those metals which are having minus values underwent oxidation, and they can pretty much act as anode. One such metal was zinc. Okay, and by thumb rule, those metals which are placed at the bottom of the hydrogen gas electrode are generally having SRP values plus. Okay, so they have a innate tendency to act as cathodes. Okay, so one such metal I chose was copper. Okay, all this is by seeing the SRP values. Now, roll number 118. Good morning. Roll number 118 is present. 19 is present.
Yes, ma'am.
19. Okay. So, Neeraj,
Yes, ma'am.
tell me what it means by SRP value.
Standard reduction potential value, ma'am.
Reduction potential. Okay. So, what it means by standard? What are standard conditions?
Temperature 25 degrees Celsius or 298 Kelvin, ma'am. And the concentration of electrolyte is 1 molar or 1 atmosphere, ma'am, when gas is counted.
Correct. So, now, Neeraj, can you tell me what factors affect the single electrode potentials or the SRP values?
Ma'am,
Factors affecting single electrode
please repeat,
potential.
ma'am.
ఇచ్చానా నాన్న నోట్లో ఇచ్చానా? ఫ్యాక్టర్స్ అఫెక్టింగ్ సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ ఇచ్చానా లేదా?
No, ma'am, ఇవ్వలేదు.
ఇవ్వలేదు. కానీ నీ గెస్ ఏంటి నీరజ్? ఓకే, సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ దేని మీద డిపెండ్ అయింది? ఇప్పుడే చెప్పావు కదా, టెంపరేచర్. Okay. The standard conditions to measure single electrode potential 25 degrees centigrade, and the concentration of the electrode should be 1 m. Okay. Otherwise, the electrode potential, whatever you are measuring, is non-standard. Then also it will have if the concentration of the electrolyte is not 1 m, still there exists the potential difference, but it is non-standard. Okay. So whenever you are saying SRP value, okay, standard reduction potential value, it means I am writing E naught value. What that E naught means? EMF value under standard conditions, that is 25 degrees centigrade and 1 m concentration of the electrolyte. And the electrode potential depends upon the nature of the metal, okay, or the metal ion, and the concentration of the electrolyte and the temperature. Okay. So, right. Please do write in your notes. Please put today's date. Okay. We'll go ahead quickly. Okay. So, what we have written? EMF series, right? Point number 26. Point number 26. The EMF series gives E naught. E naught. Understand what is E naught? Gives E naught values. That is reduction potentials. That is reduction potentials under standard conditions. Reduction potentials under standard conditions. Standard conditions are 25 degrees centigrade and 1 m concentration of the electrolyte. Standard conditions are 25 degrees centigrade and 1 m concentration of the electrolyte. Right. Next point. Point number 27. If the electrode potential is measured at different conditions, that is non-standard conditions, it is represented by capital E. It is represented by capital E, which is single electrode potential. Which is single electrode potential. Under non-standard conditions, it is just called as single electrode. Next point. Point number 27. Single electrode potential depends upon the 1 m. 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 1 A. Nature single electrode potential depends upon nature of the electrode, nature of the metal, nature of the metal or metal ion, two, concentration of the ionic solution, concentration of the ionic solution, and temperature. Concentration of the ionic solution and temperature. Okay, next. Point number 28. Galvanic or voltaic cells. Galvanic or voltaic cells are constructed considering the SRP values of various metals and non-metals. Example 1, Daniel cell, constructed taking zinc and copper electrodes. Under standard conditions. Next heading, representation of electrochemical cells. How to say that which is anode and which is cathode, how to represent. Okay, so the heading, representation of galvanic or voltaic cells. Okay. Now tell me, anode is on right hand side or left hand side?
Left.
Left hand.
Anode is on right hand side or left hand side? Come on.
Left hand side.
Anode, cathode is on
Right.
right hand side. How those two electrodes are connected? Internally.
Internally salt bridge.
Salt bridge.
By wires.
Salt bridge. Now, the electrodes or half cells are made. How they are constructed? Whenever I say electrode, in a galvanic or voltaic cell, what it is?
The rod.
What does a half cell show? Metal dipped in its own
Solution.
metal ion solution. అర్థమవుతుందమ్మా నేను చెప్పిందే. You should get this clarity. ఎలక్ట్రోడ్ అన్నాను అనుకో, galvanic or voltaic cell లో అదంటే ఏంటి? Metal rod dipped in its own metal ion solution. Okay, so how to represent? This is very important. Okay, cell representation. Point number 28. Cell representation or called as cell notation, in which I keep telling about which is anode and which is cathode for a particular cell under usage. Okay, so left hand side I'll start. Okay, I'll write anode here and the sign of anode here is negative. Okay, then what I'll show at anode, oxidation or reduction?
Oxidation.
Okay, so metal ion. Okay, whenever you are saying ion, I should write the concentration. ఇప్పుడు ions ki you should put concentration. Double lines. Okay. Then you will consider some other metal. Okay. Initially, this will be, now this is going to be cathode. And what these double lines show? Salt bridge. Okay. Here at cathode reduction takes place. So N plus electrons undergo reduction. Because I am showing the ions here, I'll write the concentration. Okay. So that is the cathode. That's how I'll put the cell notation. Okay. Anode and cathode. Right. So how to write the cell notation? What will you write after writing this? Anode, left, anode is equal to left is equal to oxidation, cathode is equal to right is equal to reduction. Okay. Single lines represent the oxidation states. Okay. And the double line shows the salt bridge. Okay. Wherever a metal ion is given, the concentration of the electrolyte should be given. Okay. That's a cell representation or cell notation.
Cathode positive, ma'am. Negative.
Negative resin. Sorry. Thanks, Nana. Okay. Cathode is positive. Good. Yeah. Adi cell representation or cell notation. Point number 29. Okay. Equation for cell EMF calculation. Equation for cell EMF calculation. How to calculate EMF of a cell? What is the mathematical equation that I'm going to use? NT. You know it? Does anyone know?
E naught of anode minus E naught of cathode.
E naught.
E is equals to E naught minus.
E is equals to E naught minus 0.06 by N into log.
What's that? What's that?
Nernst equation.
Nernst equation.
Nernst equation. Oh, you
Nernst
went
is
to
the modified, ma'am.
Modified Nernst equation side. Okay.
NF E naught of the cell, ma'am.
Sare, Harshita,
NF
మీరు
by
అనుకుంటున్నారు.
RT.
What is
Into
Nernst
log of
equation?
concentration of cathode by log of.
Sare, I have a question. No, I'll not ask you a question. No, I'll write the equation and I'll get back to you. I'll explain. You can't explain what you have spoke. I'll explain what you have spoke. Okay, just now. Okay, so I have two electrodes placed. Fine, I've constructed a cell. A spontaneous chemical reaction has brought me electrical energy. Okay, so I hope you know that. You'll accept that. Flow of charge from one point to another includes current. And the potential difference between the two is what we are talking about, E. E here shows the potential difference. Hope you know that. What are the units for potential difference?
Volts.
Volts. Okay. So simply remember, the potential difference between any 2 points can be calculated. How you define EMF? Come on, kids, buck up.
E cathode minus E anode.
Huh?
E cell.
The driving force for flow of charge, which is measured as volts. Okay. So fine, that's fine. Now charge has flown from anode to cathode. That is the thumb rule. Fine, good. So at anode there was loss of electrons and it has flown to cathode, which has deficiency of electrons actually. Okay, spontaneous reaction, very good. So that means the charge is moving from anode to cathode. Is some work done moving from anode to cathode? Now it should be logical. Is the charge moving from anode to cathode? And yes or no? Come on, come on.
Yes, ma'am.
Yes, charge is moving from anode to cathode. Okay,
Electricity
external
from cathode
circuit.
to anode.
Anode to cathode charge flow అయింది. సరే, గుడ్. వర్క్ అవుతుందా అప్పుడు?
Yes, ma'am.
Yes,
Movement
work
of
is
charge.
done. Correct. Work is done. That's it. Okay, work is done. Okay, I'll put that mathematical equation at the end. Now the charge has moved from anode to cathode. Okay, and I want to find how much charge is flown, and I have another question. Will the charge flow is directly or inversely proportional to the potential difference between these two electrodes? Question అర్థమైందా? యానోడ్ దగ్గర ఎలక్ట్రాన్స్ క్యాథోడ్ దగ్గరికి మూవ్ అవుతున్నాయి, అలా మూవ్ అవడంలో వర్క్ అవుతుంది. సరే, ఫ్లో ఆఫ్ చార్జ్ అవుతుంది. సరే, ఎంత చార్జ్ ఫ్లో అయింది మనం అది కూడా మ్యాథమెటికల్ గా క్యాలిక్యులేట్ చేస్తాం ఫార్ములాస్ పెట్టి. బట్ కాన్సెప్ట్ ఏంటంటే, సరే చార్జ్ ఫ్లో అవుతుంది, ఎంత చార్జ్ ఫ్లో అవుతుంది కూడా మనం క్యాలిక్యులేట్ చేయగలం మ్యాథమెటికల్ గా. క్వశ్చన్ ఏంటంటే, ఎక్కడ ఎప్పుడు ఎక్కువ మాక్సిమం అవుట్పుట్ ఉంటుంది, చార్జ్ ఎప్పుడు మాక్సిమం ఫ్లో అవుతుంది?
పొటెన్షియల్ డిఫరెన్స్ ఎక్కువ ఉన్నప్పుడు యానోడ్ క్యాథోడ్ పొటెన్షియల్ డిఫరెన్స్ ఎక్కువ ఉన్నప్పుడు
Exactly.
Directly proportional.
The amount of charge that is flowing from anode to cathode is directly proportional to the EMF. Antena?
Yes, ma'am.
So EMF enta ela calculate chestav? E cell is equal to E cathode minus E anode. Okay, this is the equation. This is the mathematical equation. Here the reduction potentials of both the electrodes are considered. Okay, what I have considered here? Reduction potential of both the electrodes. Okay, or this is the mathematical expression. Please write it. Fine. So anode is at left hand side, cathode is on the right hand side. So this equation is sometimes also written as marker ఒకటే ఉంది ఈ రోజు.
Ma'am, depending
So,
upon the signs, it will be plus or minus.
కాదు, సైన్ ఎప్పుడు నేను రిడక్షన్ పొటెన్షియల్, ఐ ఓన్లీ కన్సిడర్ రిడక్షన్ పొటెన్షియల్.
అది కాదు మ్యామ్. Cathode, E cathode, suppose
ఈ cathode minus ఈ anode is the mathematical formula. అంతేను, ఎప్పుడు రిడక్షన్ పొటెన్షియల్. ఇప్పుడు నువ్వు సైన్ మార్చాలంటే ఏం చేయాలి?
సైన్ అంటే ఆ సైన్ మారదు మ్యామ్. యానోడ్ ఒకవేళ ఈ యానోడ్ నెగటివ్ ఉంది అనుకో మ్యామ్, అప్పుడు నెగటివ్ ఇంటూ నెగటివ్ పాజిటివ్ అవుతుంది.
కాదు, సో ఐ కన్ఫ్యూజ్ అవ్వకు. ఇప్పుడు యానోడ్ రైట్ ఉందా లెఫ్ట్ ఉందా?
లెఫ్ట్.
సరే, అయితే ఇంకో ఈక్వేషన్ కూడా రాయండి. సబ్జెక్ట్ ఇలానే నేర్చుకోవాలి. ఫస్ట్ కన్ఫ్యూజ్ అవ్వకూడదు. ఫస్ట్ ఉన్నవన్నీ తెలిసినవన్నీ ఒక చోట రాసాయి, తెలియని ఒక సైడ్ లైన్ వేసి that's how you should study science. If not, it's pretty confusing. So ఇది రైట్ హ్యాండ్ సైడ్ లెఫ్ట్ హ్యాండ్ సైడ్ ఎలక్ట్రోడ్ cathode రైట్ హ్యాండ్ సైడ్ కాబట్టి ER minus EL. Okay, here also I considered just the reduction potentials of the electrodes. That means straight away from the EMF series I have done the calculations. Sare? Ippudu now this is more mathematical. You should tell. I think you are more confident kids. Now Sai says there can be change of sign. When? When?
When its oxidation potential is.
అప్పుడు నేను ఏం రాయాలి? Now if I say E cell is equal to E anode plus E cathode. So what did I consider here?
Ma'am, time up, ma'am.
Oxidation.
Time up, okay.
Ma'am,
I'll stop after this. I'll stop.
Sorry,
Okay,
is
just
waiting, ma'am. Sorry.
Okay, just hold on. I'm sorry. Will you tell this tomorrow?
yes, ma'am.
Take attendance from Narendra sir. Okay, I'll finish. Here, when you consider anode oxidation, when you consider oxidation potential, then the equation becomes E cell is equal to E anode plus E cathode, considering oxidation potential at anode and reduction potential at cathode. Okay, so good day. Fine. See you tomorrow.
Attendance.
Attendance, I'll not give. I'll ask Narendra sir. Okay, don't worry. Don't worry about attendance. Good day. Bye. Just